in this video, we will find cosine x plus y and sine x plus y in terms of cosine x and sine x using complex analysis. Here we will use Euler's formula, a to the ix is equal to cosine x plus I sine x, with I the imaginary number such that I squared is equal to minus 1. So let's just start. We have a to the I x plus y using Euler's formula is equal to cosine x plus y, cosine x plus y plus I, here I sine x, so I sine x plus y. And the same number a to the I x plus y, the same number is equal to distributing a to the I x plus I y. And since it's a power, it's equal to a to the I x times a to the I y. Of course, here replacing with Euler's formula, it's equal to cosine x plus I sine x times a to the iy cosine y plus I sine y. And here distributing, it's equal to cosine x cosine y, cosine x cosine y, plus cosine x I sine y, plus cosine x I sine y, starting with I cosine x sine y, plus I sine x cosine y, I sine x cosine y. And here plus I sine x, I sine y. But I times I is I squared, which is equal to minus 1. So minus sine x, of course, sine y, sine y, which is equal to, here starting with the real part, cosine x cosine y minus sine x sine y, minus sine x sine y, plus factoring with I cosine x sine y, cosine x sine y, plus sine x cosine y, sine x cosine y. Now the final step, since those two numbers are equal, the real part of the first number is equal to the real part of the second number, and the imaginary part of the first number is equal to the imaginary part of the second number. So we have cosine x plus y, the real part of the first number, is equal to the real part of the second number, cosine x cosine y minus sine x sine y, and sine x plus y, the imaginary part of the first number, is equal to the imaginary part of the second number, cosine x sine y plus sine x cosine y, or starting with sine x cosine y, sine x cosine y, just rearranging, plus cosine x sine y, cosine x sine y. And this, of course, concludes our problem.